Perfect. Wow, welcome everybody. Thank you for waiting. We appreciate it. And thanks so much for joining us tonight. We're going to get started in just a few minutes, give people time to get settled and come on in when they can. Wow, welcome everybody. Thank you for waiting. We appreciate it. And thanks so much for joining us tonight. Voice. Very cool. We're going to get started in just a few minutes, give people time to get settled. And
just got to mute that tab.
Come on in. Very cool. Love that. Love when that happens.
Been there.
Yes. Wow, welcome everybody. Thank you for waiting. We appreciate it. How many of these do I have open? Thanks so much. My goodness. There we go. There we go. Okay, you know what, since it is 7 o'clock and I know we're gonna have a lot of questions from Michelle, she's very knowledgeable. I'm gonna go ahead and get started. My name is Matt Binder. I am a program assistant here at the Schaumburg Township District Library. Welcome to tonight's program. Tonight, you are definitely in for a treat, a crowd favorites, a repeat expert on space and all things extraterrestrial, meaning outer space, not aliens. No promises in aliens tonight. Sorry, folks. Michelle Nichols. Before we get started, just to let you know, if you have any questions for Michelle, you can either put them in the chat box or in the Q&A. It's up to you what you like to do. I'm going to put a poll in a couple minutes just to let us know how many people in your house are watching. So we have an idea of how many people are attending the program. And with that, I'm going to stop talking and turn it over to Michelle.
All right. Thanks, Matt. Appreciate it. I know you all are out there. I can see the number of participants. So it's really, really great to be back with you, at least virtually. I miss you all. I really do. I have said this before. I know for some of you, this is not a surprise, but I know my groupies at Schaumburg are out there. So hi to everybody. I hope you're staying safe. I hope you're being well. So tonight, we're going to talk about Mars, and that is because it is a very timely topic. We've got some Mars-related stuff coming up over the next few weeks. So without further ado, let's get started. I do want to reiterate what Matt said about putting your questions in the chat or the Q&A. As you think of them, go ahead and put them in. Because I'll stop a couple of times and look for questions. So you don't have to wait till the Q&A time at the end to ask a question. Do that anytime. If your question refers to a particular picture or something I have up on the screen, just put a quick little reminder as to what was up on the screen when you were asking your question. So that'll help me out a little bit. So like I said, I'll stop a couple times. And so with that, let me share my screen. All right. Hope that all looks okay. Actually, hang on. Wait a minute. I'm stopping sharing for just a sec. And then I'm going to, yep, my mouse is acting up a little bit here. There we go. Okay, let's get started, everyone. So we call this Roving the Red Planet, and there is a lot going on over the next few weeks. Earth is invading Mars in February 2021, starting next week. So you may have heard that NASA has sent a spacecraft to Mars called Perseverance. It is not the only spacecraft headed to Mars as we speak, as we're doing this program. So the first one that is going to arrive is this one. This is from the United Arab Emirates. The spacecraft's name is Hope. It is called Al-Amal. It translates as the word hope. This mission is a first for the United Arab Emirates. It's their first interplanetary spacecraft. It's going to study the atmosphere of Mars. And there have been spacecraft that have studied the atmosphere of Mars before, but not comprehensively, not as the major thing that spacecraft will do. The spacecraft will also give scientists the first detailed understanding of Martian weather at large. So we're talking about across the whole globe of Mars throughout the day and from one season to the next. There were several partners that the United Arab Emirates called upon for helping them to build and operate this spacecraft because it is their first. Wanted to make sure they got some experienced folks participating in the team. The team included the University of Colorado at Boulder, Arizona State University, and the University of California at Berkeley. So wish them much luck. It's arriving February 9th. So in just 5 days, this spacecraft will go, we hope, go into orbit around Mars. Now, the next 2 slides look complicated. I'm not going to explain everything that's on them. These slides were the only images and only drawings that I could find that were decent for this particular spacecraft. This is arriving February 10th. This is a Chinese craft. Its name translates as questioning the heavens. I'm not going to attempt to pronounce the name in Chinese because I know I will not pronounce it correctly. So I don't want to disrespect that language. So just know that the name translates as questioning the heavens, pretty much what all spacecraft do. So I think it's a very appropriate name. This mission will, among other things, search for water under the surface of Mars. And so it will consist of an orbiter. So it will go into orbit February 10th. It consists of a lander plus rover. And so we've got a drawing of the lander plus rover. There we go. So this is the rover portion. And the rover is going to drive off the lander, and it will have a radar on the bottom of the rover. So it will be able to search for those underground pockets of liquid water if they exist. So this is the first time an orbiter plus lander plus rover has been sent to Mars. We've sent orbiters, we've sent landers, we've sent landers and rovers, we've sent just rovers. But never before has it been a combination of all 3. So very exciting. And again, this is going to arrive in orbit on February 10th. Then arriving on February 18th, we have the Perseverance rover mission. So I'm going to talk much more about that. But you may be wondering, wait, is it a coincidence that all these spacecraft are arriving right around the same time? Was that planned? Well, not planned from one mission to the next. So like they called them up and said, hey, when are you getting there? That didn't happen. However, there are periods of time when we send spacecraft to Mars. And that happens around the time when Earth and Mars are closest to each other. So that is when they're on the same side of the sun. And we call this opposition. Now, launch usually happens a little bit before opposition. And so then opposition occurs when the spacecraft is partly on its way, and then the spacecraft arrives. And so what you're doing when you're sending spacecraft in this way is you are essentially aiming for a spot in space where you hope the planet will be when the spacecraft gets there. So it's not like they're sending the spacecraft to a stationary place. They're sending it to a place where the planet will meet up to be able to then send it into orbit. It's going to slow this. You're going to slow the spacecraft down just slightly for Mars's gravity to capture the spacecraft, or in the case of the Perseverance rover, it's going directly to landing. There's no orbiting, get it just right, and then land. No, this is direct to landing. And you're aiming for a specific spot on Mars. And I'll show you the specific spot on Mars that they're aiming for in just a little bit. But let's first go over some things that we know about Mars. So just make sure we're on the same page with that planet. So we've got the first 4 planets from the sun: Mercury, Venus, Earth, Mars, from left to right on your screen. And Mars is, of course, the one on the right-hand side. We call it the red planet. As you can see from this picture, it is not red, not like a stop sign, not that color red, but it is kind of a rust color. We're going to go over some of the features on the surface in just a little bit. As far as size goes, Mars is about half the size of Earth, and our moon is about half the size of Mars. So coincidence that it's that way, but it's interesting to at least think about. And then to give us a sense of the volume of this planet, because we've got the diameter, how about the actual round size? Well, if you have a hollow Earth ball and you filled it with Mars marbles, you could fill it with a little more than 6 Mars marbles. So yeah, it is kind of a tiny place. Earth is the largest of the rocky planets, and so then Venus, then Mars, then Mercury being the smallest. All right, put this another way to get a sense of scale. If you take all the land mass of Earth that's above water and you compare that to Mars, it's about the same amount of surface as Mars. So just remember, though, that 70% of Earth's surface is covered in water. I'm talking the 30% that's above water. That whole amount of land is equal to the land surface of Mars. So people ask a lot, why do we keep sending spacecraft there? Don't we know everything? Haven't we been there, done that? And the answer that I like to give is try to characterize all of planet Earth by landing in 10 or 15 locations. You can get a pretty good sense of what is on a planet or what a planet is like if you send an orbiter there. You can learn about the surface. But the only way to start to characterize what's there, how it works, what the geology is, what the history of that place was, is to really get down on the surface. And that's why we send these spacecraft there and why we continue to send these spacecraft there. The Martian gravity is about 1/3 that of Earth's gravity. So yeah, you would hop along a little bit more like this astronaut does here. Well, let's put it another way. A 100-pound person on the Earth weighs only 38 pounds on Mars. Yes, instant weight loss. Well, not really. You're not losing any portion of yourself. You still are made of the same amount of stuff. It's that Mars's gravity is not pulling on you as much as it does as Earth's gravity does here. So when you come back to Earth, you still weigh the same amount. You're still made of the same amount of stuff. So anyway, it looks good on the scale, but maybe not in reality. Mars is the 4th planet from the sun, and it's about 1.5 times the distance that the Earth is from the sun. So yeah, the sun is a little smaller in the sky, not quite as much energy on the surface. It's a little bit dimmer out there. But we can send spacecraft with solar panels, for example. They can still operate using the sun, still plenty of energy for that. And temperature. On Earth, the average surface temperature of Earth, highest to lowest, day to night, all that taken into account, the average temperature on Earth is 57 degrees Fahrenheit. The average temperature on Mars is 81 degrees below zero. Not a balmy place. But that doesn't quite paint the entire picture for what Mars is really like. The next slide with the weather report over the last week of Mars, or about a week ago, so a high temperature, for example, on January 24th on Earth, the 3011th day that the Curiosity rover has been on Mars, it was a balmy 0 and a low of 99 degrees below zero. Or January 25th on Earth, the 3012th day that the Curiosity rover has been on Mars, a high of 10 and a low of 101 below. You may be wondering, how in the world is it this cold? Why such a range? And the answer is Mars's air is a lot less dense than Earth's air. It's about 1% the air pressure at the surface of Mars than we have here at the surface of Earth. So there's not much air to move any heat around. You might be warmer at the very surface, and a few feet above the surface, it could be markedly colder. Again, there's just not that much air to move around all that heat. So you can have a daytime temperature of 5, 10 degrees and a nighttime temperature at more than 100 degrees below zero in the same location. So this is a pretty harsh place. How about another way to measure how harsh it is? How about radiation? This is a radiation map of Mars. The blue represents a little bit less radiation. The red represents more radiation. And so what this boils down to is if you're at a higher altitude, you are exposed to more radiation. If you are at a lower altitude, blue, you're exposed to a little bit less because you've got a little bit more air above you blocking some of the radiation. But basically, the surface of Mars, you experience a lot more radiation than you do at the surface of the Earth. We have a magnetic field to protect us. Mars does not. We have more air to protect us. Mars does not. So there are many factors into why the surface of Mars is actually pretty harsh. If we ever send people to Mars, we're going to have to take this into account to be able to protect the folks who are living either out on the surface or underground or in a cave or something like that. How are they going to be protected from much less air, stuff we can't breathe, higher radiation levels? This is something that is going to have to be worked on to be able to successfully get people to Mars at some point in the future. All right. Mars has two moons, Phobos and Deimos. Phobos means panic. Sorry, uh, Phobos means fear. Deimos means panic. Oh, geez, and I'm getting those words mixed up again. Phobos comes from the word phobia. That is fear. Deimos comes from the word that means panic. I hope I got those right. Somebody correct me in the chat if I didn't get those right. I've done this twice this week. I need to put it in my notes because the more I talk and the more I mention it, I go, wait a minute, did I get them mixed up again? So anyway, if someone could kindly put it in the chat, the difference between those two or what those translate as, I would appreciate it. Anyway, so just take a look at the sizes of these moons. If you stuck them within the borders of the city of Chicago, you'd have room left over. These are tiny places, right? Phobos in particular is orbiting Mars only about 3,000 miles up. For comparison, our moon is 240,000 miles from the Earth. Phobos is slowly getting closer to Mars. Eventually, Mars's gravity is going to pull it apart. That won't happen for another 30 to 50 million years, so you don't have to worry about it. But this will happen at some point in the future. It will not happen to our moon. Our moon is slowly getting away from the Earth. It will never go away completely. But there is a difference between what's happening with Mars's moons and what's happening with our moon. All right. We think those moons were at some point possibly the original objects were captured asteroids. So, all right, you can see the surface of Mars. It looks really interesting. It's got those three splotches there off to the left. We'll get to those in just one more slide. But the gash in the middle, that is called Valles Marineris. It's Mariner Valley, and it is an extraordinarily large canyon system. It's not the deepest cliff or anything in the solar system, but it is a pretty deep canyon. It is over 4 miles deep at its deepest point. For comparison, the Grand Canyon is only about a mile deep at its deepest point. The Grand Canyon is about 200 miles long, give or take. This canyon is about 2,000 miles long. And so it's a surface feature that takes up a good portion of the size of the planet itself. Now, what are those splotches that I mentioned? Mars has volcanoes. We don't think they're active. We've not seen any evidence of volcanic activity, but these are shield volcanoes. And what that means is some magma from the interior of Mars erupted. It's magma on the interior, liquid rock, melted rock, and it's lava if it's out on the exterior. So it erupted, formed the volcano, and this hot spot kept erupting, and these volcanoes get taller and taller and taller. That is a shield volcano. Olympus Mons, there to the upper left, is the largest volcano in the solar system. It is over 70,000 feet tall. And an equivalent type of volcano on the Earth is Hawaii. And on the big island of Hawaii, you've got a volcano, a shield volcano. There's a hot spot that keeps erupting in the same location, but the crust of Earth is different from Mars. Our crust moves. Mars's crust does not. And so our crust is broken into plates, and the plates move around and run into each other and all sorts of things. Mars's crust, as far as we can tell, has never done that. And so whereas the big island of Hawaii, the volcano erupts, but eventually the crust moves the island to the northwest. And so off to the northwest, you've got older and older islands. Those smaller islands used to be where the big island is now, and they used to be bigger. As they get older, as they get farther to the northwest, they erode into the ocean. So this did not happen on Mars. By the way, notice where you've got one edge of the big island and the other edge is Kauai. This is to scale. So both in terms of the size of the islands and the distance between them compared to the diameter of Olympus Mons. This volcano is so big, it's got the diameter of the state of Arizona and the square mileage of the state of New Mexico. It's really big. And so tall, these volcanoes regularly, almost daily, have water ice clouds around their tops. We see water ice clouds in other places on Mars too. It's not uncommon. These clouds were seen over Gale Crater, which is where the Curiosity rover is right now. It occasionally takes pictures of the sky, so you can see some really wispy water ice clouds here too. Just we see these on Earth. We call them cirrus clouds. It's neat to see them in the atmosphere of Mars. Okay. I'm going to go back real quick to this picture. This picture makes it look like Mars is just the driest of dry deserts. But we've been finding out over the last about 50 years, Mars is not a dry desert. Mars is a frozen desert. Here's one example. This is a crater that was formed approximately 2008, late 2008. Something from space smashed into the surface, made a crater about 4 feet deep. And that white stuff that you see in the left side picture, that is water ice. It's ice that was under the surface, that the crater, that the thing from space, when the crater was formed, that ice was excavated, kind of splashed out a bit. And then a few months later, when they took another picture of the same spot, they saw that the ice had basically vaporized. So there was ice under the surface, and it no longer exists in this particular crater. Here's another example. This was a picture taken by the Mars lander Phoenix about 12-ish years ago. And basically, Phoenix had a scoop on it, and it scooped down into the Martian surface. And about 2 inches under the surface, we find water ice. So you can see these 3 little ice bits, kind of ice chips, there on the left-hand side picture. On the right-hand side picture, in the same exact spot, they're not there. They didn't walk up and move away. They vaporized. The Martian air pressure is so low that when this ice gets exposed, if it's a small amount of it, it will basically vaporize. It will turn to gas. The dust and stuff over top of it keeps that from happening normally. And if this ice gets exposed, then it will vaporize in a period of time. Now, this next map is a little confusing to start with, but bear with me. This is another ice map of Mars. Let me explain. First, imagine a round globe of Mars made into a flat map. That's what this is. The North Pole is the top of this rectangle. The South Pole is the bottom part of the rectangle. The equator runs along the middle of the picture. The black areas that are here, basically there was a science team that said, okay, where on Mars has just the dustiest of dusty surfaces? Like if you landed a human spacecraft on Mars, where would you most likely sink into the dust because the dust is thick enough and that wouldn't be enough to hold your spacecraft up? That's what those black areas are. And the purple areas, the blue and purple colors, they've identified that those areas, there is water ice there, less than a foot below the surface. The red colors on this map, water ice is also there, but it's a little deeper. It's about 2 feet or more below the surface. The white box, the white outline box, the science team said, okay, let's pretend you're going to send people to Mars in the future. where would it be easiest for them to land, so nice and flat or relatively flat, and there's water ice that you can actually use for something. You could take a shovel and just dig down in, and there it is, one scoop, and you've got it. That's what that white outline box is. If you're going to send people, maybe you might want to aim for that part of Mars. Really interesting to think about all that, right? So anyway, let me stop for a second. I see there's a couple items in the Q&A, so I'm going to stop sharing for just a second. And I'm going to go back and take a look. Thank you. Phobos means fear. I'm going to, hang on. I keep thinking this. I'm going to write it down. And Phobos is fear. And I'm going to change my notes. Thank you very much. All right. So the cosmic ray environment slide, what is the very dark blue section? So let me go back to that slide. And I'll share that one again. All right, so I know which part you're talking about, so let me share that. All right, so that very dark blue area, that is a really, really large crater. It's Hellas Basin. It is an enormous crater, several hundred miles in diameter. But because it's so wide, it's also really deep. So even though the surrounding land mass is at a higher altitude, that area is especially low because it is just such a giant crater. One of the biggest craters in the solar system is that crater right there. But also you can probably notice the northern hemisphere of Mars is at a lower altitude than the southern hemisphere. Not exactly sure what happened with that in the past, but that's the way it all works out. So anyway, big giant crater is what that is. So great question. All right, there is another question. Where is the optimal place for a craft to land on Mars? So when we go back to that other slide, this one. So an optimal place is usually, number one, where it's flattest. So you don't want to land in areas where there's big giant rocks and boulders, that sort of thing. You want to also look for a place that's closer to the equator, just because it's easier to land near the equator. If you take a look at a picture of the moon, where they've mapped out the locations of where like all the Apollo landings were and all the other landings, they're relatively near the equator, within a band around the equator. It's just easier to land a spacecraft there. It's much harder to land it at the poles. You have to do more to your target, to your orbit, in order to get to the poles. So optimal place, you want to land where it's easiest, land where it's flattest. So near the equator-ish, near where it's flat. But in this case, that science team that made this drawing, basically, or this map, basically said, okay, near-ish the equator, fine, we're in the northern hemisphere. Let's look for some resources that we can use. And that would be where the water ice is. So you don't have to drag it all with you. So the water ice, how is it useful? You can break it apart into hydrogen and oxygen. You can breathe the oxygen. You can use the hydrogen for fuel. You can melt it, drink the water. So there are lots of different reasons for wanting to go to this particular location. You can land in the more purple areas. They're just closer to the poles, and it's just, from a physics standpoint, it's just harder to get to those areas. Not impossible, but it's just a little harder. That's all. So there you go. I'd say they got it pretty spot on. This is probably a pretty optimal place to land on Mars. So, all right, let's go on. So this map indicates all of the landers that have ever landed on Mars, either successfully or not so successfully. Anything that's in kind of that light gray color, those were unsuccessful missions. You've got Mars 2, Mars 3. Those were Soviet Union missions, and Mars 6. Schiaparelli and Beagle 2, Those were European Space Agency missions. They did not land successfully. That slightly yellowish tannish color, those were successful missions. We've got all the way back to Viking 1 and Viking 2 in the 1970s, Pathfinder in 1997, Spirit and Opportunity in 2004. Phoenix was, I believe, 2008. Curiosity 2012. Insight in 2000, I believe it was 18. The ones that are in blue, Mars 2020 is the Perseverance rover. ExoMars is a rover that the European Space Agency will get to Mars. It will launch in 2022. So got a couple more years before that one is going to actually get to Mars. So there have been a Mars Polar Lander that was not successful. That should have been in the latter 1990s. That one crashed on landing, unfortunately. So anyway, we've had a lot of missions go there, but let's really talk about the rovers. I call this talk Roving the Red Planet. Everyone loves the rovers. They move. They do interesting stuff, right? So this is a set of family portraits of the various rovers. The little tiny guy, that is Sojourner, I should say tiny gal. It's named after a lady, Sojourner Truth, an abolitionist from the 1800s. And so Sojourner was part of the Pathfinder mission. Then Spirit and Opportunity are represented by that rover on the left, and Curiosity is represented by the rover on the right. And you can see a large size difference between what we were able to send to Mars 25 years ago versus what we're able to send to Mars today. Perseverance is even slightly heavier than Curiosity is. The chassis is the same. How the wheels basically work, that's the same, but the science instruments are all different. So we started seeing evidence for water on Mars decades ago. And this ties into what Perseverance is going to be studying. So bear with me. Following the water is what we've been doing for literally decades. We started seeing evidence in Mariner 9 images of Mars in 1971 that, gosh, there are really some features that look like they were carved by liquid water. Take a look at this Viking 1 image. Does that not look like a dried river? Sure does to me. But the scientists had to ask, was it due to water? Could it have been something else? This is an image of a place called Gusev Crater, crater about the size of the state of Connecticut. This is where the Spirit rover landed in 2004. Take a look at this one. Sure looks like that was a dried river, or that's a dried river. Maybe that was a liquid water river that maybe flowed into and filled up that crater at some point. Well, that's what they thought. So they said, all right, this is where we're going to land. We will study the rocks and look for signs that liquid water may have been here. And that's what they did. So they landed Spirit in 2004 and kept testing rock after rock after rock. Every single rock they studied on the floor of the crater was a volcanic rock. Basically, just your normal, average, everyday Martian volcanic rock. Nothing exciting, no evidence of liquid water whatsoever. So then, after a while, the mission lasted long enough that Spirit could start driving up into some hills. And they thought, well, maybe there's some evidence up here. This particular location, if you see the white stuff that's in that image, they went and studied that white stuff. That's silica. Silica is called silicon dioxide. This sample that they studied right here is 90% silica. You can't get that much silica without water playing some part in concentrating that mineral. It just doesn't happen by itself without water being in abundance. The origin of this silica was likely a hot spring. Rocks were also tested in the area of this silica that only the minerals that they found only form in the presence of water. Here's an example of that. The rocks on the right are on Earth. You get minerally hot water flowing through cracks in rocks, and the water flows through, the water dries up, it leaves the minerals behind. That white stuff is calcium sulfate. One form of calcium sulfate you would know as plaster of Paris. Another form of calcium sulfate that you would know is the mineral gypsum. If you're not familiar with gypsum, you probably are. If you've ever knocked a hole in your wall with your hammer and you tear through the drywall paper, that crumbly stuff underneath, that's gypsum. So on Earth, you need water to make gypsum. And calcium sulfate minerals. There's no other way we know of to make that stuff. And so the picture on the right is showing calcium sulfate minerals on Mars. The same process as we have on Earth happened on Mars. So here was that evidence that liquid water actually existed, hot, briny, minerally liquid water. How about another example? This is Gale Crater, where Curiosity landed in 2012. If you look off to the distance in the picture, that looks like mountains off in the distance. Those are the walls of the crater. Curiosity landed in the crater, in the flat spot. Again, easier to land where it's flat. And the goal was drive toward the mountain in the middle. And the mountain in the middle is called Mount Sharp. And they said, well, if we go study those rocks in the mountain, presumably the rocks at the bottom are older, the rocks farther up are younger. We can learn about the history of Gale Crater by studying these rocks and let's see what we find. Well, all right, so they started driving Curiosity, driving. They noticed some rocks that looked interesting on the floor of the crater, not too far from where Curiosity landed. That's the picture on the left. The picture on the right is a dried stream bed in Chile. The picture on the left is a dried stream bed on Mars. This was a freshwater stream, not hot, briny water, not salty ocean water. We've seen evidence for that elsewhere. This was freshwater, a freshwater stream. You could drink this water. What happened was, and now that you know what to look for, you can see there looked like a stream running down the side of the crater, and the water fanned out and it puddled in the bottom of this crater. So imagine that you've got water puddled in the bottom of the crater, kind of spreads out, overflows from time to time, and the water kind of sits there and dries up. What does it leave behind? Mud. That's what this is. This is ancient dried mud on Mars. Looks like it happened a few months ago, right? Looks exactly like here when you're walking through a forest preserve and it rained a couple weeks ago and left some puddles and they dried. That's exactly what this looks like. And this is a cycle that probably repeated itself over and over and over millions of years. Here we've got ancient dried clay on Mars. Why is that significant? You need water to make clay. There's no other way to make clay. You need water to do it. Certain minerals plus water equals clay. That's what this is. And that hole is Curiosity's drilling down into the clay. And then when they lifted the drill back up, it kind of started to pull some of the clay with it. So anyway, this is Mount Sharp. Because the layers were formed with water and wind, those rocks get younger with height. And what they've been studying and what they're going to continue to study as long as they can is the different layers. And you can see there's different colors, right? You can see there's this kind of grayer layer here. Up above that is a different color layer. Even up above that, there are different colors. So seeing these different colors is important because the different colors tell you about the different minerals inside those rocks and the different fluids that passed through those rocks. So the different water, what it contained. Did it contain anything with minerals? Was it just fresh water? Anyway, you can see the difference in the different kinds of rock here. The outside, the color may all look pretty much the same. The inside, the colors of these rocks range from an ochre red to a blue gray. And that's strictly because these rocks are all different from each other. And so piecing together the geologic history of Mars is piecing together what kinds of rocks and minerals we see. All right, so I'm going to stop for a second and look for, I see another Q&A. All the landings are in approximately the same area on such a large planet. Why? Is Mars round or oval? Mars is definitely round. So let me go back to that landing. Hang on, I'm going to Come on. That image is really big. The image of Mount Sharp is really big, so it takes a second for my PowerPoint to register it. So let me go back. Okay. You noticed, and actually good observation, that these landings are all basically near the equator. It's just physics and mechanics. It's just physically easier to land near the equator. You're launching from nearer the equator on Earth. The planets are all in the same plane. And what I mean by that is um, our solar system is basically all the planets are fairly in the same flat sheet of paper. And so when you're launching from the middle of one, you're going to end up in the middle of the other. If you want to try to get to the poles, the top or bottom, that's a lot harder. And so it takes a lot more effort to do that. So all of these, especially a lot of these that were earlier, we didn't have the technology or the capability to land near the poles, not till later. So landing near the equator was definitely necessary because it's just physically easier. And also, we're not able to land in every place on Mars. There's a lot of places that the rocks are jagged. They're enormous. There's a lot of them. There's only so many safe flat spots to land on. So you're seeing the exactly what the scientists have noted, that there's only so many places that we can land. However, our capability to land in certain places is getting a lot better. Our area on Mars that we can land on is getting smaller, meaning the target area is smaller. And that's good. That means that opens up more places that we can land. Because if you land anywhere within a certain target, you got to make sure that if you land literally anywhere within that target, it's safe for you to land. Well, the smaller your target is, the more you can pinpoint your landing site in a safe place. So there you go. All right, a couple more questions. What was the temperature range when Mars was covered with water? Excellent question. Basically, it probably was warmer than we've got now. So Mars, for it to have liquid water on the surface, it would have to have been warmer, and it had to have had more air pressure. And so this was likely literally in the far distant past. We're talking a billion years or more in the past. But the temperature range would have had to have been high enough that water could still be liquid on the surface. So 32 degrees Fahrenheit, at least. Doesn't have to be much warmer than that, but it has to be at least warm enough for water to be liquid, or at least there's enough air pressure to have water stay liquid on the surface. And someone else asked, are there toxic substances on Mars? There's toxic substances everywhere. So yes, so probably toxic to people. I'll give you an example. The air is mostly carbon dioxide. If you breathe in and you breathe out, you're breathing in nitrogen and oxygen. You're breathing out nitrogen and carbon dioxide. Basically, Mars's air is almost totally what the carbon dioxide you breathed out. That's toxic for people. So we have to have an air supply there that is different from the regular atmosphere of Mars. Travel time to Mars. Basically, all those 3 spacecraft that I showed you that are arriving next week and the week after, they all launched in July. So travel time is July to February. So approximately 7-8 months ish to get to Mars. It's pretty normal to be able to do that. So there you go. All right, let's go on. Just a sec to get back to where I was. And that picture always takes a while. There we go. All right, we're in the home stretch. So the Perseverance rover used to be called Mars 2020. So that's the picture the drawing on the right. The drawing on the left is the Mars Science Laboratory, aka Curiosity. By the way, if you're ever looking at a drawing and you're not sure which rover you're looking at, you're going, is that Curiosity? Is that Perseverance? Just look at the treads on the wheels. Angular treads for Curiosity, straight treads for Perseverance. Basically, one thing they noticed with Curiosity was its wheels had not too long after it landed started getting pretty chewed up by sharp rocks. They were starting to see punctures in the in the wheels themselves. And so those wheels aren't filled with air or anything like that. They're essentially like metal type wheels with a coating on the outside. The coating was getting kind of chipped up and the wheels were getting punctures from sharp rocks. So they've tried to make Perseverance's wheels a little more sturdy. So you'll see differences in the treads between the two. That's my first sign for which one is which. So I almost wish they could like paint them a different color or in big letters paint the name on the side or something like that. But Perseverance's mission has several objectives. Number one, find rocks that formed in or were altered by environments that could maybe have supported life in the past. Not necessarily looking for life in those rocks, but finding the rocks that could have been altered by life in the past. Find rocks that are capable of preserving chemical traces of life. Like, did life leave behind some chemical trace that we could find? Drill core samples from some rocks, and we'll come back to that in just a little bit. But also, there's a test. I mentioned the toxic substance of carbon dioxide on purpose because they're going to have a test um, scientific instrument on this rover to capture carbon dioxide from the air and try to turn it into breathable oxygen. Not that the rover needs it. They want to see if they can create oxygen reliably from the air of Mars, which is toxic to humans, carbon dioxide. So, how is this thing going to get to Mars? Well, you're going to watch this and you're going to go, who thought of this? All right. So, coming up the afternoon of February 18th, Perseverance will arrive. It has a heat shield at the bottom. It's kind of a cone-shaped spacecraft. The heat shield will protect it from the heat of reentry. Um, After it slows down just enough, the parachute will come out. It will go from supersonic speed to subsonic. The heat shield drops off after a certain altitude. It's no longer needed. Then the sky crane comes down. It will slow down some more using rockets. And then the rover itself will be lowered by cables to the surface. Once surface is contacted, the cables are cut and the rockets continue to fire to take the sky craner away, and it crashes because it's no longer needed. So you're probably thinking, who thought of this? And how in the world is this? Do we know that this is going to work? And the answer is this is exactly how Curiosity landed. So um, they've used this system once before and it worked then. So that gives us confidence that it will work again. So they're aiming for this spot. So the whole giant crater is called Jezero Crater, and they're aiming for that dark circle oval. That is a spot 6 miles wide. They're aiming for a 6-mile wide spot on a 4,000-mile wide planet. Pretty amazing, right? So not only are they aiming for Mars to be at that exact spot, they're basically aiming for that exact spot of Mars to be in the right spot for the spacecraft to go from space to the ground. And it'll land in one piece or it'll land in many pieces. Either way, it's landing in that spot on Mars. Now, you may think, well, wait a minute. You don't want to aim for what looks like some cliffs or something there. It actually has the ability to be completely autonomous when it lands. It will be able to sense dangerous terrain and move itself a bit before it lands, to move the whole system before it lands to try to avoid that dangerous terrain. It will do it autonomously. There's about an 11-minute signal delay between Mars and Earth. So it's not like you got people on Mars running joysticks or anything like that to get this thing in the right spot. It will have to do it all by itself. So we'll see how that goes. It's how we've landed other stuff before. So the green in this picture is showing you a mineral called carbonate, or there are minerals called carbonates. On Earth, those minerals are especially good at preserving evidence of past fossilized life. So we'll see. If life ever existed on Mars, if it left anything behind, this is as good a spot on any on Mars to be able to find it. So can't guarantee that it's there. We don't know. Just because there's carbonates there doesn't mean there's evidence of life there. Could just be there's some carbonates there and nothing else. But we'll see. We'll see what we find. Now, eventually, we want to get some of these rocks back to Earth. This mission won't do that. But what they're going to do is get ready for that. The rover's going to land at some point in the crater. And it's going to drive around and find some interesting rocks here and there. It's going to drill into about 30 of them. It's going to sample up several rocks and put them in tubes. And it's going to drive around to some more spots and get some more rocks and put samples in tubes. And then it will put those tubes in one specific location. And these tubes are in case we're ever able to send a return mission to go get those tubes and bring them back to Earth. We don't have that on the drawing board. It hasn't been designed yet. It hasn't been paid for yet. We're not necessarily going to do it anytime soon. It could be 6 years from now. It could be 10 years from now. We'll see. There's at least interest. But when we're ready, the tubes will be ready to go with rocks all sampled up. And that mission won't have to do that. So how would it work? This is a future possible mission. This is a set of this is a drawing to describe a mission to return rock samples from Mars. This could be a partnership between the European Space Agency and NASA, and different pieces would be provided by both entities. There would be an orbiter that would arrive first. Then later, a lander arrives. So the orbiter goes into orbit, does its thing. Later, they launch a lander that would land and carry a rover. In this case, it's called the Sample Fetch Rover. The Fetch Rover will go gather up those tubes and bring them back to the lander. It will give the tubes over to the lander. The tubes will be put into the carrying compartment attached to a rocket. The rocket will launch and take that stuff up into space. It will deploy that special container with the rock samples into space. The orbiter will then rendezvous with the container and capture it and hang on to it, bring it back to Earth. Sounds even crazier than the animation that I showed you of how they're going to land Perseverance on Mars. So, hasn't been designed yet, but there is some science fiction out there about how to potentially go get those rock samples, because we got better systems on Earth to be able to study those rocks than we could ever send to Mars. So one demonstration mission that is actually going to be along with Perseverance is a helicopter. This is called Ingenuity. And again, it's a demonstration. It has a solar panel at the top and 4-foot long carbon fiber blades. They're going to attempt to have this thing work on Mars and fly. If it works, it will be the first controlled powered flight on Mars. Again, it's a demonstration mission. It rides on the bottom of Perseverance, and it's going to drop it off at some point, and Perseverance will roll away out of the way. It might work. It might not. So we'll see. If it does work, if that first test flight works, they may do up to 3 or 4 more. And there are a couple cameras on the bottom of Ingenuity, and Perseverance will be able to watch with its cameras as well. All of its cameras, it's got 23, 24 cameras, and they're all in color for the first time. So hopefully Ingenuity will be able to get some images or video of itself, and Perseverance will be able to get images or video of Ingenuity flying, which would be pretty cool if you ask me. So if everything goes well with the landing, look for Ingenuity to be dropped off probably in around May or so. And then the test flight would happen sometime after that. So that basically gets us to the Perseverance mission. Let me check a couple more. What caused Mars to lose its atmosphere? Basically, Mars does not have a magnetic field. Earth does. And that magnetic field protects us from solar activity, solar storms, flares, and other things. Normally, if we didn't have a magnetic field, our atmosphere would just erode into space. That a passing debris cloud from the sun would just start to erode, start to carry away some of our atmosphere. And that doesn't happen. On Mars, there is no magnetic field, so that happens. So its atmosphere was eroded into space with no magnetic field, and Mars's gravity is a lot less than Earth. So it just didn't have the gravitational pull to hang on to that atmosphere as well as Earth can hang on onto its. So kind of a two-pronged answer there. Carbon dioxide is a greenhouse gas. Why isn't Mars warmer? Is the atmosphere stable? Does it leak out into space? Carbon dioxide is a greenhouse gas. If it wasn't, Mars would be colder. And is the atmosphere stable, or does it leak out into space? It leaks out into space. Absolutely. There is another spacecraft I didn't mention that has been orbiting Mars for, since 2014, called MAVEN. And MAVEN stands for something. I can never remember what it stands for, but the goal of that mission is to study Mars's atmospheric loss. And so MAVEN has been studying the actual loss of the Martian atmosphere into space. So is that a telescope behind you? I knew one of you would ask about that. Yes, it is. Hang on, let me turn a light on and you'll be able to see that. Yes, what do people wear for Zoom programs? They wear jackets and shorts, right? So, all right, here, let me turn this on. And I need to take a look at the video so that I can see what you can see. And there we go. It's a little bit extra light. And a telescope here. Matt and I were talking before you guys got all let in that this is something that if we were in person at the library, I couldn't do this. I can't bring this telescope with, but yes, this is a telescope. This is one of the Adler's telescopes. So it is a relatively small telescope, but it can track. And then this one over here, this one's a lot lighter. This one is one of our telescopes for scopes in the city. So this is one of our outreach telescopes. There you go. So this telescope we use for our outreach programs, which of course we have not been doing since March of last year, unfortunately, due to the pandemic. And then, I just put the telescope in front of it so you can't see it, but do you see that gold telescope right back there in the back? That is a solar telescope, and that is used to only look at the sun. So that is a telescope that all three of them are telescopes that we occasionally put cameras on and take pictures, and we use them as part of some of our online programs, online to YouTube programs that we've been running since last summer. So anyway, there you go. Telescopes. Probably you had no idea that I would be doing that in this program. That's why I kind of really like doing these programs from home, because I can sometimes go into topics that I wasn't otherwise planning on talking about. So any other questions before we end for tonight? Oh, I think one just popped up. Check. Will this program be available to watch again? Matt, I know this is going out to YouTube. Is it going to be available after the fact?
Yes, you can find it again on our Schaumburg Library YouTube page. So look for it there.
Excellent. How many books, as in the books that are behind? Those aren't actually books. Those are CDs. So yes, we are some of the people who still have a big giant collection of CDs and vinyl records. So there you go. The books are upstairs. So yeah, no books down here. They're upstairs. But yeah, those are CDs. So yes, you all are seeing my house. Is the big guess is there was a civilization on Mars long ago and no longer survived? No. That we've seen absolutely no evidence for any sort of organized civilization on Mars. We're talking, if there's any evidence of life, we're talking microbes, bacteria at most, something like that. But no, there's nothing that we have been able to see that has made it look like there was anything like us um, on Mars. Boy, wouldn't that be cool though? So, am I wearing shoes? Slippers. So there you go. Boy, you guys are really getting deep into the questions here. Will there be live coverage of the landing from Earth, not from Mars, of course? Yes. So NASA is going to have coverage of the landing starting at 1:15 p.m. online. The Adler Planetarium will also offer a Mars rover landing watch party. So we're going to have that from the Adler. We will be at the Adler. No one else can come, but we will be broadcasting live to our YouTube channel from 1 to 3 p.m. on Thursday, March 18th. March 18th, sorry, February 18th, Thursday, February 18th, 1 to 3 p.m. YouTube.com/Adler Planetarium, totally free. You can chat with us in the YouTube chat. You can watch. We will be there at the Adler showing some of our Mars exhibits. We've got a couple interviews with a couple Perseverance mission team members. We're going to record those a week from tomorrow. So it's going to be really fun. So if any of you do come, please say hi in the chat. I'd love to give Schaumburg Township District Library a shout out in our program. Oh, thank you so much, Tom Walsh. Great program, and thanks. We hope you do a lot more of these. Me too. Either in person or online when it's safe for us to be in person, of course. What are they doing to avoid the dust storms? They're not. But the one thing that curiosity and perseverance can do that spirit and opportunity could not do is spirit and opportunity ran on solar panels, and eventually dust does settle on the top of solar panels and it cuts down on the amount of energy you receive from the sun. Curiosity and perseverance run by a different power source that doesn't rely on the sun. So in that way, they don't have to avoid dust storms. They can still keep operating no matter what. You might just get dust settling on stuff, but it's not as big of a deal for perseverance and curiosity as it was for spirit and opportunity. So, are the rovers affected by Martian sandstorms? Not these two. Uh, opportunity, its mission ended because of a really big dust storm, really dark dust storm that basically cut the sunlight down to zero. So, what caused the huge gash or canyon on Mars? Ooh, all right. I'm going to give you an example, a situation that all of us in Northern Illinois can relate to. Imagine you have put a terracotta pot outside somewhere. You had some flowers in your terracotta pot, and fall rolled around, and you might have pulled the flowers out, and the dirt is still in the terracotta pot, and maybe it rained, but all of a sudden, oops, you did not get the terracotta pot back into the garage, and it froze. And November, December rolls around, and your pot's out there outside, and it froze. Okay, fine. Spring rolls around, March, April, May. You go outside and you try to lift up your terracotta pot. What's going to happen to your pot? It probably broke. Why is that? Because the dirt got wet, the water froze, and ice takes up more room than liquid water, and it expands and it breaks your terracotta pot. That's basically an example of possibly what happened to create um, the Valles Marineris Valley Canyon on Mars. The interior of Mars used to be molten in some way. It solidified. That solidness takes up more space. It expanded the planet and basically tore a gash in it. Just like your terracotta pot, just like my terracotta pot that was outside about 5 years ago that we didn't bring in time. So I betcha some of you can relate to that story. But that's how we think maybe Valles Marineris formed, is the interior of Mars solidified, froze, and expanded and actually cracked the planet. Not a deep crack. I mean, it's a 5 mile deep crack. It's not huge, but still big enough. So thank you so much for the kind words, everyone. I'm seeing some very kind comments. And Matt just put our Mardi Gras Mars Rover Landing Watch Party link into the chat. So if you want to grab that, just click on it and it'll take you to the landing page. Just go to the adlerplanetarium.org page, kind of scroll down, and you'll see all of our Mardi Gras celebrations. By the way, Mardi Gras is the 16th of February. So we took a little liberty. Mardi Gras, Mardi Gras. Hope you don't mind. So, all right. And thank you so much, Mary, for your kind comment. Matt, anything else from you before we end?
No, I think it's very funny that our conversation came full circle with
It did.
questions about. As always, great questions from everybody. Thank you once
Oh,
again, Michelle.
wait a minute.
Oh,
Someone
we have
said
more questions.
someone said chat is oh, wait a minute. Oh, hang on. It said chat is disabled, can't see the link. I think it might be, hang on. I think it went to all panelists, so I see it. Let me see if I can send it to everyone.
There we go.
Let me know, folks, if you can see that. If not, I'll put it, well, if it doesn't work, if you can't get it, just go to adlerplanetarium.org and scroll down about halfway down on the homepage, and you'll see the link to our Mardi Gras landing page. So you can't miss it. It's the only picture on the homepage that has Mars with a Mardi Gras face mask on it. So you can't miss it. So, all right.
All right.
I
Well, thank you
think
once
we're
again,
okay.
Michelle.
Thanks. Oh, there it is. Now they see it. All right. Yay. Okay.
All right.
Thanks, everyone. Stay safe, be well, wash your hands, wear your masks, all that fun stuff. And if we can't be together at the library soon, it's all right. Hopefully we'll be together online, and I will see you either virtually or in person at some point. Thanks a lot. Appreciate it.
Thank you. All right, everybody. Have a great night. Thanks so much.
Good night.